same, 16 on center, Southern Pine number 2, there. So this is the thermoply house, John. This is the thermoply house here. So here's my spans. Get your trusty tape out, the Southern Pine, and oh, where am I? And they were actually under the 18 feet at that time. Now they'd be way off, wouldn't they? So, but 19.5, so they were almost 1.5 feet over because it was bedrooms above.
Were they using 2x4 cage?
No, they were not.
Yeah, mine are 2x4.
So now they can only go 15.8.
Wow.
So big significant difference.
You get 20 foot.
They get them. They got them. They put them in. I couldn't figure it out. Drilling and notching. We know, I'm not going to spend a lot of time, but you don't put any cuts in the middle span of the member or any notches. You can put holes, but you can't put notches. Why? Because but why in the middle? That's where you have the most bending, is in the middle. Okay? That's where you can get failure. And then of course you've got your depth divided by 6 is how deep you can go in there. On the ends you can do the depth of the member, depth top to bottom, divided by 4. You're allowed a little bit more because you don't have as much tension load here. You get mostly compression load here. They come in large cuts, and they come in extra large. And then, same limits apply to girders, just so that you know. So these framers died, so that's in the cobwebs. That's another picture. And then, of course, you've got hole sizes for framing members, just like you did the studs. In order to qualify for a hole and not being a notch, you need either 2 inches, at least 2 inches of wood on the bottom and on the top. If you have any less than that, it's a notch. And the reason that's important is because in this case here, you're allowed to go 1/3 of the depth. You were only allowed 1/6 of the depth, but you can actually go have a twice as big of an opening with a hole because of that extra wood. And notice how it says actual. So a 2x10 is 9 1/4. Okay, so you divide 9 1/4 by 3, not 10 by 3. Okay, so that's critical here. And that leads me to this. Okay, so we look at it and you do these little things, and 4 5/8 for 2x10, is that more than 1/3? Doing the math, it's pretty straightforward, isn't it? Because that's almost half, right, of 9 1/4. And then you see multiple cuts in there, and I just wanted to illustrate this for 2x10s, that if you got 9 1/4 divided by 3, you're a little over 3 inches. So bathrooms, minimum requirement from a commode is 3 inches for a water closet, they call them. They usually use 3-inch Schedule 40, right? Well, the ID of that is just under the maximum hole size. The OD is 3.5. So if you've got 3-inch pipe, you have violated it for a 2x10. Okay? Don't hesitate to sit there and tape. If it's 3-inch, write it up. And then, remember, is that 2 inches from the edge? Yeah, from the top, you're right. Bearing is important too. The ends of each joist, beam, or girder, so that it doesn't discriminate. 1.5 inches. Okay? And that's wood or metal, but it's 3 inches on masonry or concrete because this is much more brittle. If you brought it there, it could shear the corner off. That's why. So you need more surface area to spread that load out. And you know, I got the question yesterday, yeah, but where's the plate? Well, you may run over to a garage floor. It may run over there or something. It may run over to an area where the plate's on top for the wall. and there's no plate right there. So I've seen it run into a crawl space to just a little divider wall or something like that. You don't see it too much. These are the great ledger strips there, that aren't really an inch and a half. They're quote unquote 2x2s with the round edges. If somebody ripped them, they're probably going to have enough bearing, but when you buy these ones that are rounded, they're not enough. You're supposed to be out here and you're here. Also, look under stair landings for bearing. So right here, they probably should just get some joist hangers in there, right?
Especially older construction.
Huh?
Especially older.
Oh yeah, you'll see it all the time. This is new to the 2012 code. I think it came out to 2009. Have you guys ever seen this in there? When you're on a sill plate, the plate has to be 4 to 8 inches. What are they talking about? What they're saying is if you use a 2x4, you got to at least be 12 inches long if you're putting something on it. Yes, sir.
You're gonna see this violated almost exclusively in crawl spaces where they're piers.
Yeah.
Almost always.
Matter of fact, there's a code change about that. They're actually addressing that for the 2018 code to give a very specific size. Because they're tired of looking at the shims and everything else that are falling out.
Well, I've seen them cut, just cut the ends off a 2x10, just an inch, and use that.
Yeah.
To hold up a lambda.
Yeah, exactly. It's just a misunderstanding of load transfer. So what they're doing is they're creating a surface area to transfer this. That's what they're doing. And what if it was a 2x6? How long would it have to be?
Longer.
No, shorter. Because you only have to get 48 inches. So 48 divided by 6 is, hey, you guys are getting it. Wanted to show you something that was actually added to the fastening table. If you're using a ledger strip to support joist or rafters, you gotta have 3/16D nails at each joist or rafter.
16. Wow.
You think that thing's gonna stay intact and not split? Not if they use that little rounded one. So it's probably just better to use a joist hanger.
It used to be.
Huh?
It used to be.
Back up. It's number 31 on that table. Big table right at the beginning of chapter 6. Do you have permission to move on?
Mr. Jewett,
Yes, sir.
remember the old Forest Products manual for decks?
Oh, yeah.
And it said in it that you can't drive enough nails into that 2x2 to support the deck load of 40 pounds a square foot.
And I asked all those engineers. That's why I was surprised it was in the code, because I remember Keith and I asked a bunch of engineers one time, and they said the same thing.
The 2x4 ledger?
No, the 2x2. You got a 2x4 ledger, you're all right, but 2x2 ledger.
Oh, no, 2x2.
Yeah, that's what we're talking about.
Well, where's your nail location on the 2x2? On each side of the joint?
It's supposed to be right underneath it.
Right underneath.
3 of them.
Can't you just turn that 2x4 this way and face nail it and put them on?
And then hang straps?
Have you ever seen that?
No, I haven't.
Well, I have. Oh, yeah.
Where's this at?
It was in crawl space.
Oh, okay. You still do crawl spaces, Gary?
Some decks, I've seen decks where they face nail a 2x4 and put the joist on top of that.
Well, I see that definitely for stairs.
When he's young, he can turn that deck around backwards like this.
Who, Gary? Gary's as old as me, aren't you?
Probably
Yeah. What we got here, guys? Huh?
Well, it's not attached to that thing.
Well, you're on the right track, so what's another term for that?
Post and beam.
Post and beam construction.
Positive connection.
You gotta have positive connections there. You can't just go in here at that point. See, what happened was, is this scenario, they overspanned because they picked up this load here because for some reason they realized they needed to build, this was a custom house. They popped this in and this thing started deflecting, so they put a post in. And so, problem is you cannot achieve that positive attachment through toenailing.
All right, is this sitting on some kind of base or is this sitting on a concrete slab?
That was another story. That was another story. Yeah. Yeah, but that positive connection is for uplift and lateral loading.
And what would that look
Well,
like?
they attached it with their staple.
Well, I'm glad you asked. See, I'm anticipating. You know why? Because I've done this so much.
Put the most cap on it now, though, isn't it?
All right, let's talk about this. I know I mentioned this before, but according to my sources, I have anonymous sources too, and my anonymous sources say that this is still a prevalent issue here. So especially for you, if you guys heard this last year, you can tune it out, but if you want to be reinforced, the new guys watch this. So if they've got a joist hanger, everything's cool, right? Got an issue here. Simpson's got a publication that basically says when you have a joist, you got to cut it to the correct length. Don't shortcut it. You need to get your, remember when your dad used to say, get your joist stretcher? So you got to make sure that that thing's not shortcut. The gap between the end of the joist and the header should be no greater than 1/8 of an inch. Got to be tight. And just so that we know, USP also does it, and trusses are in the mix. This would be engineered I-joist, trusses, joist, anything. Any type of material that has a bearing capacity in a design that you cannot have a gap more than 1/8 of an inch. Okay? So they can't just be sloppy. But see, truss members have to bear fully in the connector seat, be cut to fit against the header, and the gap can't be greater than 1/8 of an inch. So that's the industry standard. And then you see this, and I think we could say that sometimes you might need a yardstick to measure that, right? That's a joke. You guys are tuned out.
If it's a deck, you might need a yard.
Yeah, that's true. So, but you can see that these things all are over, you know, 1/8 of an inch. Okay? Why is that an issue? Simpson has a nice little publication in their technical notes that basically say that what happens is if you have a properly installed joist here, no more than an 8-inch gap, you've got proper load transfer from the connector into, through the fasteners into this beam. If you,
Now, the nails they provide are 25/8-inch long nails, and they can go in straight, but what about when you're toenail? Is there a different?
we're actually going to deal with that. That's double shear nailing. That's coming up next. So yeah, but I thought you were going to actually bring up another point, because one of the things, and be aware of this, that down the road we're going to actually probably see some issue that Simpsons, especially for decks, are probably going to want to go screws, because the withdrawal, you're not supposed to use any fasteners subject to withdrawals for decks, and those hangers are subject to withdrawal. So just throwing that out for food for thought. So anyway, if you actually go greater than 1/8 of an inch, now your load's sitting back here. You're not fully seated, and you're back here. And what it does is actually creates more downward twist force on here. That hanger was not designed to take that, okay? Because it's supposed to carry the load spread. It's almost similar to when we were talking about the concrete. You're spreading it out, but now you're just on the back thing. It wasn't designed for it. And then, because you asked for it, double shear nailing, okay? That, if you have no gap, you've got your nails that come into the side that you actually attach, because it's not just to put the joist in the slot. You also have to connect it to the hanger and bring it into the framing member. Okay, this is fine. You've got good wood here coming each side, and that's called, again, double shear nailing. You get a scenario where you get a small gap. Look how much less wood you have compared to here. See, so that's what's happening now. You're only picking up less, and then if you get too far, you have no nail penetration. So you're really not supporting it the way that connector was designed. That make sense? So you got a new thing that you can find out there. You have plenty. Yeah, John.
See, it's most common with roof trusses. So they got the roof trusses hanging off a hanger. Almost every house you see that on.
And show them a picture?
Go for it.
All right. Because I want to show them repair options. So they show, the question is how to repair it. I would just say to your builder, if they ask or your client asks, say, recommend checking Simpson's technical bulletin and just give them the number and seeing if there are repair options for what you have. Good way to put it, keep it vague. Okay? You didn't tell them how to repair it. You referred them and say, see if you have any options there. But one of the options would be to actually, what you do is you take the hanger off and you put a wider hanger. Instead of a single hanger, you put a 3-ply hanger and put, I hate the word scabs. Why do they use that word? Why don't they just say sisters or something? You know, but they would put blocking in there, they put on each side, and you actually will fasten it there, and you pick them up all, and now these scabs go all the way to the end and you don't have the gap. So that's one repair option. And again, you got a roof truss here, and the same thing here, that you can also actually put a shim in there and put a new hanger on there. So those are two ways that it can be addressed, okay? And this is actually John's picture, what he's showing. This is a roof truss that's coming into a truss girder, and this is one that has been repaired. I know we're on floors, but we're going to talk about roofs too, because the hangers can be used for either. Engineered wood products, we got to be careful about cutting these things, right? I-joist. And that kind of stuff happens because either most of the time the framer he started at the wrong end of the house. That's a lot of times what will happen. You know, everybody blames the plumber, but in this case, the plumber had a water closet. There's only one place to put this, you know? So it was really a framing issue. And do the framers have wiggle room, even if they come across and say, wait a minute, this was an architectural plan. Robert, put your head up. You didn't do it. But, you know, maybe they didn't put the joist in the way, but note that almost all the manufacturers, this is Weyerhaeuser, will allow you to shift that framing member up to 3 inches. Okay? You know, if you're able to, if you gotta be careful, I mean, if the floor sheathing, you gotta make sure you support that and everything, but you can shift that over 3 inches, and you only do it with one member, it's okay. You know, rather than compromising that top flange of the I-joist. Maybe you end up having to do another joist in there if you do, but that's a pain in the neck if they have a pipe or wires in there. Everybody know about holes and I-joist? Every manufacturer has a way of doing it. Weyerhaeuser is the simplest. Boise Cascade actually includes the span of the framing member as an element of designing how big of a hole you can put. None of the manufacturers are going to allow you to put any type of cut right here because there's a lot of compression force right there. And we're talking about that OSB web material, okay? And then they've got distances from holes or rectangular round holes. It's usually 2 times the greatest dimension. You have to have minimum separation. And then these charts basically give you, if you want to put a 5-inch hole on something that's 16 feet, you've got to be at least 4 feet 3 inches away from either bearing point. Okay, that's really what it is. So it's kind of a little different than our notching of floor joists, because what we're doing here is we got to keep it away from these compression points. We want to keep it out. The larger the hole, the more distance you want. So this kind of stuff is a bad place to do it because these are all compression points here, and they've completely screwed this up.
I have seen that, right where the end of the joist, while I fix it up and butts into that. Even if they didn't have, but the ends of I-joists, are they not supposed to be squash blocks or squash?
We're getting there. We're getting there. Don, you're gonna be my PR guy. I'm gonna hire you for my marketing. Because you just prep everybody. He is my, I know, he is. He's a plant. I'll pay you later, don't worry. So this is almost comical. Alright. And then the HVAC guy's a beaver. Chewed all that. Bam, bam, bam. And then, well, the deck's secure. Again, this is a bearing point right here. So this, now this is subject to compression forces. These guides are great. You really need to have a file for them depending on the manufacturer. Again, you can download it on your phone if you're on the job site. Just look and see who the manufacturer is of the product. And you look for the detailing of your I-joist. And you know, they give you areas that they've labeled, and then they'll you go to that section, and then they will show you a greater detail of fastening and extra additional support. I'm going to focus on B2 because Don wanted to, so I'm going there. And we're going to talk about blocking. When you have a load-bearing wall above here, you may have to include squash blocks. In this case, they're using 2x4s that are a little larger. They're 16th of an inch larger to pick up that load and protect that flange there and that web there. And they might even require a web stiffener, which would actually go between that blocking and the OSB. And again, you got to look at the details. Typically, like if you have a cantilever or something like that, you're going to require that. Okay, but this is one thing that you'll see required in here with a load-bearing wall. And again, when you have hangers that are top hangers, you don't have to have any web stiffener. You can have a gap in there. Okay, because it's picking up the top and the bottom flange. If you got a joist hanger that goes all the way up to the top flange, that thing's not going to rotate if they don't have a spread. However, if you have a hanger that's too short that doesn't go all the way up, you're going to have to put a web stiffener in there. Okay, what does that look like? Looks like that. This is where you need a web stiffener in here, because that hanger did not go all the way up to keep it from rotating. And same thing here. Probably didn't have it. These are high enough, but because they had a double, they just, they were out there back ordered.
Is that across multiple manufacturers? Is that kind of the standard?
Yeah. And that's the thing, and that's a good question. That's kind of like I was showing you with that header. It's the wood I-joist manufacturer, and they actually have used the ASTM to set their industry standards. Matter of fact, when I see issues like this, and you're looking for, you can cite manufacturer's installation, but you also, at the beginning of chapter 5, you can also cite that they got to conform to that ASTM 50 whatever standard, and that's all the installation and design standards. So, you want that one? That's the one you want? Okay. And sometimes you're going to need backer block if you're using doubled up I-joist as a girder. It may require you to put filler block in there to stiffen it, and you may need to have a backer block to install when you're actually hanging it at that point. Okay? Again, that's the H2, and I'm not going to spend a bunch of time just showing you some of the possibilities that you might find issues. I'm bringing this up just to show you. I was showing you truss joist, which is Weyerhaeuser. I'm just showing you that it does go across into different manufacturers, because this one right here is Boise Cascade, and they've got the same detail. Okay, so most brands are going to tell you the same thing. The reason I said most is because there are some obscure ones that I'm just guessing they probably would if they're going to follow the standards. But you can see a situation here where they did put the backer block in. So I will show correct installations too. See the backer blocks there.
So what is that needed now? I guess I don't quite understand.
Well, you're using this guy as a girder. He's picking up all these loads here. So in this case, it's a real short span. This is the bottom of the stair. So when you bring that in there, you're using this member as a girder. It's just a single eye joist, sometimes even double. You've got to have a backer block here because you're resting that flange there. You're actually trying to transfer surface area into this member. Okay? And then here, they're missing it. So now they only got the point right here. So now you're loading up that bottom flange with the weight and maybe the top flange there. So you're again trying to spread the load. And then sometimes you'll actually use one of these with the backer blocks, but oops, we forgot the hangers. So sometimes they'll have a combination of issues as well. So then we also have squash blocks. This is similar to what we're talking about, but instead of having a bearing wall, we might have point loads from a lot of different things. They transfer the load. They'll bypass that eye joist. Okay, they help that member being protected from being crushed. Okay, manufacturers require this. Okay, and a lot of times a good builder, their lumber or their supplier will actually make a plan for it, and it's going to be in the box a lot of times. So just to demonstrate, we have created a window. We put a header in here, right? Okay, got a header right there. So we're carrying all the loading from here. We're bringing it around each side. Okay, now we got point loads, don't we? That's not a uniform load. We got point load here and here, and if we got eye joist, we may need squash blocks there. Okay, so you'll see again, they're supposed to be 1/16 of an inch, and a lot of times you might say, well, they're not there. How are you going to put them in? Well, they should be kind of hammering them in, this stuff, huh? So anyway, so that's what you should see there on each side of the framing member. But they need to match whatever the bearing area is above. If it's wider, they might need more. You can get them from window openings, door openings, or just again a column load. This is an example of a plan that was on site when I did the inspection, and all those are places where you're supposed to have squash blocks. It makes it easy to find. We got a point load here coming down from above here, and we got a little bit of a problem here. In this case, we've got this eye joist is like in a stairwell. I got a load coming here, and it's actually crushed. I wish I would have had this picture. I couldn't find all my pictures in it, but this one was just all terribly destroyed on the other side. LVLs, they're strong, but you got to be careful. Sometimes they're not allowed to have any cuts. There's specific areas where you're allowed to and not allowed to touch these, so be aware of what they are. Open web trusses, we want to be aware of those. The obvious things are you don't cut any framing member on these because they were designed to work as a system. They need to be engineered corrected. The manufacturers do tell you, don't touch them, okay? This is Robert's language. Don't do it. Right, Robert?
Can't you just fill that with the fire caulk and?
Well, they do. And sometimes you got a little bit of something that you're not as aware of. See, you got all these double-ended trusses here. Well, somebody broke one off and then they put some filler in there.
That'll be in a staircase.
That'll be in a staircase. You got it. And then this was one that had too much load on it, and at the end, sometimes the plates pop. Just write them up. This is just showing you, I'm actually at a manufacturer's website showing you that they've got pneumatic presses that they actually put these in, okay? And they have portable ones that they can come out to jobs. I'm gonna show you this here, okay? That's a hydraulic press. That was the only picture I had. And I know I showed you guys this last year, but I had a house that was over $2 million on Riverside. Probably over 60% of the trusses from the basement were popped like this. They spent a couple days out there with a hydraulic press fixing them all. Okay? But how much is too much of a gap? 1/8 of an inch, you think? Is that good? Sure, why not? Okay, let's look at the 2012 IRC. So we're in the floor section, which is chapter 5, right? And this also would apply to the roof section of chapter 8 for trusses as well. They have to be designed, for use. They have to comply with ANSI TPI 1, that's a standard. And here's the ANSI TPI 1 standard here for plate embedment. Okay? Because this is not that great of a picture, I'll say that the maximum gap is 1/32. And what I'll do is I'll take that table and put it up here. So you got a gap up to a 32nd of an inch, you get 100% effectiveness of the design value. You go from a 32nd to a 16th, now you're only at 60% of the design value of that truss. You go from a 16th to a 3/32nd, now you're only at 40, and once you're 3/32nd, think about that. That's not very much. You have 0 of the design value because it's almost not even touching because those things are only so long. So be aware, if you see them pop, write them up. Okay? And just to show you that these are actually, they have a over-design, a safety value in it. If they are actually no gap, they really are 119%. So also I'll point out ladder trusses should not be put in span. Any truss that's put in span should have a diagonal in it. This one right here only has verticals and it should not be in span. Where should this be? It should be used on a wall. It's a ladder truss. It's like a little knee wall. That's the only place it can be. It cannot be in span without a diagonal. You'll find them occasionally. Attic framing, just real quick, I'll pop some. When should a GAHI inspector go up into attic framing?
Winter. In the fall.
When it's requested in writing by a client? Is this true? Is that true? Who's that? That's Paul Maxwell. I gotta tell you, Paul, one of the younger inspectors came up to me and said, "Get him down from there, he's gonna fall." Paul, tell him how old you are.
75.
That's Paul, that's 2 years ago, buddy. I ain't afraid of no height, am I? But it just shows you're so used to it, and there's a careful way to be up there. But you did scare a guy. He aged 10 years when you were up there. And Alex knows who I am. I'm talking about. Alex was afraid for you. Remember that, Alex?
I was impressed. I asked him what it was. Apple cider vinegar.
All right, so I got a rafter up here with a bad chunk out here. Can I write that up as code violation?
Is it just a split?
It's not a split. It's just a big old nasty knot, long knot. So I can probably say that it possibly might be a load issue. I can go 801.2 that the rafter may not be sufficient to transfer a load, or I can say that we got a grading issue.
That's not 2 members, that's one.
That's one member, that's a rafter. So you might be able to use it from a load perspective, or it's not graded properly. Okay, because lumber is visually graded. How many times do you send lumber back that says it's supposed to be one thing and it's twisted or knotty and everything like that? Huh?
A lot.
Yeah. They try to pass out garbage on these guys all the time.
It's gotta go somewhere.
That's right. So there's a couple of codes I want to look at in here. There's a code 8023 that talks about ridges, rafters, hips, and valleys. Ridge boards can't be any less than the depth of the rafter. And same with hips and valleys. The jack rafters, when they come into it, when they hit a hip or a valley, that valley or hip has to be able to have provide full bearing for the jack rafters. Okay, and hips and valleys have to be supported at a ridge. So this is a scenario where you're not getting full bearing at a top at a ridge. Okay.
When you cut the corner off, then you are.
There you go. Yeah, you go like that. Yeah.
diagonally cut the point.
This is what happens when you end up with non-support. What happens is these things move and they twist and you'll get cracks. So, the bearing on the ridge stopped there. This is unsupported, and all the way down the line I had cracked rafters because you get a lot of movement. Okay? No full face bearing here, is it?
See, when you touch it, most of it touch it.
They are.
It's-
When you have where a ridge and the hips come together, you gotta have bearing up there. Sometimes you'll see these little gables or these little bump outs, these little dormers I should say on the front there too, and they'll just be floating out there. Supposed to have support there. Sometimes our rafters are bearing on the toes rather than the heels.
No rafter ties,
Well, that's another thing. But who remembers the whole wall? Remember that? One of our inspectors said that? Golly, that's too old, I guess. Maybe that was 20 years ago. But you can see that we're only bearing on the tip and not out here. See some cracks starting to form on that as well. So that's completely not bearing in there. And I think I showed you this last year that this is from the Journal of Light Construction. It's showing correct, incorrect. But the problem is that is not IRC compliant. You can't use that as a source. So what would you do? Well, the IRC actually put a diagram in, the 2012, which really helps us a lot. Okay? And basically, it says when we cut the ends of a member, it can't be greater than 1/4 of the depth. Okay? And we look at that, and it's right here. See? You start cutting it up and pulling it out there, okay? See, that's 1/4 of the depth right there. So you can use that code if you want to deal with it. And then sometimes you got to just make it, dude. Because friction fit ain't getting it. Is there such a section? What's the maximum overnotch in a purlin? Paul? None. Thank you. Purlins, just to show what they're there for, they're designed to allow you to use smaller size dimensional lumber for your rafters. Because when you measure rafter span, you measure it from where it bears at the top to where it bears on the wall. That's your span. For the size of the roofs that we use, 2x6 shouldn't be able to be used if you ran them from all the way from the midpoint to the end. And I'll show you why. If we go 18 feet from the ridge to the wall, and we're using 2x6 Southern SPF number 3, what we need to do is put these guys, these are those purlins right there. They're running this way, and this is a T-brace coming down to a bearing point. And what we're going to find is that what's used a lot for stick-built attics, SPF number 3, 16-inch center, maxes out at 10 foot 10 inches. And so we're well overspanned for 18 feet. By doing the purlin, it's a girder. We measure from the ridge to the purlin, and if we're at 7.6, we're within the 10.10. We go up here and do the purlin to the wall, and 10.6, we're still within the 10.10, and that's why we can use it. But if you're going to, you're going to run into this lot from houses that were built up to about 97. The code actually allowed you to use 2 2x4s flats. Doesn't mean they're right, they just allowed it. Okay? But 95 cable, we adopted it in April of 97, and they actually said that purlins have to be the same size as the rafters they support. So when you look at that, this guy didn't get the memo. Okay? And then also, purlins have to be continuous from bearing point to bearing point. Makes sense, it's a girder, so you don't splice it.
All right, so when you say it's purlin, you're saying remember, it's like at the top of that brace, that's perpendicular, you know, that's edge nail, support.
The purlin is turned sideways. How many times do you put a floor joist flat, like a plank? It doesn't work.
Well,
So
that's what I'm saying.
that's what I'm saying, that's gotta be
The boards didn't work.
correct.
We don't throw them away, we just added the 2 to 6 on top of them, right?
Well, the 2x6 has to be supported, you
It
can't,
has to be nailed to something.
yeah, this right here, you've got a purlin here, and then there's a brace on the back side. A lot of times you see this brace go up and support the brace.
Okay.
This is the purlin.
Okay, gotcha.
Yeah, but you know what? I can show you picture after picture of unsupported purlins. You will find this is probably the most common violation you have. Though.
What is the specs on the brace?
It's got to be a minimum of a 2x4, okay? And it's got to, if it's over 8 feet, it's got to be braced. They don't tell you how to brace it. We see angles connecting the braces, so an unbraced brace is unpermitted after 8 feet of length. And then Paul, if you guys want to talk about Paul did a lot of research on it. He'll get into a lot of the detail of purlins about things. But one, I will address one of your issues, the compound one. I will address it. But there's also a maximum span for a purlin, 4 feet. You can't go over 4 feet, and then you got to put a support in. So you have compound purlins, okay, at compound angle. So that purlin's this way to the rafter, right? So it's one angle, but sometimes it may be kicked over because you may have a tray ceiling or something. So not only is it going out this way, but it's angling this way. They're not effective. They're not doing anything really, okay? This is what happens if you try to sit something on top of it. It doesn't even fit. So compound angle braces are not effective. Okay, what they should have done is run a couple of, like an LVL or something, and bring it down to the LVL, because you can't put it on the tray ceiling. That's really what it is. You'll see a lot of that. But don't forget about ceiling joists. They need hangers too, right?
Another option, they could have stepped up to a larger size piece of lumber than they had carried.
That's true. That's true. Just want to point out that there's a publication that both Chapter 5 and Chapter 8 of the truss sections defer to. You can use it for the bracing of your trusses for attic and stuff. I'm going to get through. You guys have ever seen trusses like this? These are called piggybacks. They are 2 sections of trusses. The number one thing that you don't see in here is the diagonals. So we're at the living areas down here. We go up and they're missing these diagonals. I've rarely ever seen one. I had a situation I'm going to show you that the builder didn't know, or the framers didn't know why these things were longer. They're longer because you got to have lateral bracing, continuous lateral bracing. And so this actually kicks this top truss up higher to put those in there. Didn't know what they were, so they cut them all off on both sides. And this is what it looked like. They were flat and nice, but what's missing? Well, that's how we attach them. There's no lateral bracing there. So, and then this is one that does have the continuous lateral bracing, but they don't have any diagonals up there. Again, you'll be writing that up all day long.
Would a 1x6 work at the time?
You're going to have to look and see what the spec is on it. You don't get damaged plates, drilled holes, missing plate, cracked webs. These are things that we need to look for in here. So where knots are, they're going to crack. If you see them put a sister on the side, one side, it's probably improper. You don't say it's improper, you say recommend confirming that the repair was done correctly. Most engineer truss repairs require a solid repair material on both sides of the break. Here, they just thought more nails they could use, that would work. That doesn't work. This is proper. Pulte actually had a design repair drawing down below showing the nail pattern was right, so this is correct. See how they got the crack one, and then they got a 2x4 on each side. I know we're getting late, I'm going to whip through these a little bit, show you. Now this is a great picture because we also got to be careful that if we got too much load on this thing, we got to make sure we protect it. In this case, this is Russell's picture. This last truss, the bottom cord's too small compared to these, so they actually added some framing material. Is that 2x4? Is that what that was?
It's a 2x4 cord, bottom cord there.
Yeah, what they've done is, so this is designed to have people and HVAC units on it. So they had the wrong size truss there, and they just filled it up there to connect to the floor sheathing. And you've got to make sure that these are designed for all the loads for units and people going up there. You're going to see this a lot. They missed putting the plate over the connection. He did it there. Sometimes they'll miss them. A real easy way to remember for you new guys is to check whether floor trusses or roof trusses. Stand on one end and look down the line. You'll just see where they should be and they're missing. That's a real easy way to pick this up. And then just do it from the other end as well. And that one's, they should have seen that's right at the opening. Gable ends. Usually you're going to see them going this way, but the biggest thing is there should be blocking between the roof trusses to transfer and share that load, because this is the gable end wall that's got wind going in on it, okay? And so, this house right here, it wasn't very well done, but they had it there, but it went down to a single truss that had broke off. Actually broke off there. This is what we're trying to resist happening. By not having blocking in there, it's just going to move. And like this, what the heck is that? What does that do? You just see a bunch of stuff that they just throw out there. Nothing on this one. There's nothing on this wall. You want to see the outside of that wall? That's what happens when you got a brittle material, whether you have brick or stucco. It's going to move and it's going to crack. That's what it's really doing there. So now this is a weather barrier, don't forget. Now you just compromise the weather barrier. Foundation, real quick, that's what you're going to deal with a lot. Because these brick ties, not brick ties, but foundation ties will leak. We're almost done. I want to deal with just a couple things on some flashing issues, okay? And windows. A lot of times you'll see them cut the straps on these windows before they put shims in. What happens is that window will bow. Two things will happen. Well, one thing, if the window's closed, if you unlatch it, it pops out if it's a pop-out window, and it can be dangerous. Second thing is your little window test, try to lift it. Because it's bowed here and pinches here, you can't really lift it up. It'll stop pretty quickly. So keep an eye on looking out for these things, because the problem is what you need to do is you don't say it's installed it properly. You just say notice no shims. Recommend confirming that the warranty is not voided. Good way to put it in your report. Because really that's what you're trying to avoid. Yes?
Something that I've seen every now and then on these truss frame roofs, you go to the building, the roof's all done, look over on the burn pile, you got 2 or 3 crushed trusses burning on the burn pile. Somebody made a mistake here.
Oh, you'll see that a lot. 2 quick things here. What about the flashing on windows and doors? So we'll put on this window here, we'll go ahead and put house wrap on this thing, okay? Okay, what you're supposed to do is cut this back, right? And pin it up, and you apply flashing in a shingle fashion. So you put your bottom flashing in there, put your window in, and then you run up your flashing on the side. Typically you're seeing peel and stick. You run it across the top, then you bring that down and tape it. That's how it's supposed to be done. Okay? And when you see this stuff, it's just slapped on here, and the house wrap actually came under the window there. You're going to have leak points. I mean, this is a nice high-end home, and it's a shame, and they're good quality windows. Two installation instructions were violated here. Okay? One, the window manufacturer provided their own installation instructions of what I just showed you. And the house wrap manufacturer, same thing. So, I mean, it's out there, so, but you'll see this a lot out there. Because a lot of times the windows can be in when you're doing the framing. Let's talk about drip edge for roofs. Okay, the code in chapter 9 says eaves, which are the gable roofs, that angle side. Gables are there, and then these are considered eaves. This is where the gutter is. Okay, you're supposed to overlap any splices 2 inches. It's got to extend a quarter of an inch over the decking here, and it's got to extend at least 2 inches out onto the roof. These are minimums. Okay, if you have when you fasten it, you got to put a fastener every 12 inches, and the underlayment is required to be over the drip. You're supposed to go, well, the language is really horrible, but essentially what it is that you put that flashing over that felt along that edge, and then you bring it under here. Okay? Makes sense. And there's Gary's finger hidden by a glove. So what happened is that drip edge didn't even go up to the sheet and get it.
I did one yesterday, brand new roof put on.
Yeah, I did.
5 days ago. The homeowner came home and said, "Should I pay the roofer?" I said,
Yeah, that's okay.
They-
He was a seller of the house. I said,
Around,
"The flashing doesn't
130,
need to be
230, something like that.
Yeah.
I checked 6 inches. Didn't touch it. The president of the company called me while I was at the roofing company. He said, "I put 6 inch on there." I said, he said, "Yes, it is. It's right here on the paperwork." I said, "Well,
Why don't you come out?
what's over there is not the same." He said, "Well, we're not having it fixed." Everyone was doing exactly like that.
Yeah. I know. No.
So they forget sometimes the builder's gap is 6 inches.
Right. Well, and some of the other problems these guys run into is it's really the responsibility of the roofers, but your trim guys are.
They need to put another, 1x2 or something there, they need to put something there.
They need to get their trim guys out first, doing all that stuff, and then let the roofers put the roof on. Also, we got to make sure that we have kick-out flashing. That's required no matter what the siding. Like Bill's crying over not on stucco, because when we see it not on stucco, that wall is all full of water and it's compromised.
Same with stone too.
Yeah, same with stone, but it's required on all sidings, and it's supposed to kick out this way. This is a scenario where the flashing died in the wall and just poured into a chimney chase. So it's missing there. This is what it should be. It should come down and kick out over. Like that. And then just a few more things you can look at. You got electric siding. It's one thing. You violated the manufacturer of the air conditioning unit. And you've created another mold problem, probably. Safety tempered glass, good time to check it. A lot of times the painters take the windows out and they don't put them back where they're supposed to. That's one thing, so you might find them there. Yeah, Paul.
A friend of mine's house just burned 2 weeks ago. 15-year-old house. The fire inspector determined that a staple had been driven through a wire, and then finally, over the years, sparked.
Wow.
And burned his house down.
Wow.
15 years.
Wow. You might have an opportunity to see that if they haven't put the insulation in. I'm gonna shift through this one real quick. This is the one we want to watch, stairwell stuff. If you've got windows in a stairwell less than 36 inches from the imaginary line that goes over the ends of the treads, and you're less than 36 inches at the top landing and less than 36 inches height, these are required to be safety tempered. Okay? And you should see a label on it. It's got to be permanently put on that glass. Also, you've got one, if, you know, remember this landing too, the same thing. If I don't like the change because it used to be less than 60, but now this, if it's above 36 inches, not required. But look here, watch these things. This is an area where you're required to do it. So I got this on a framing inspection going into a garage. And then bottom of the stair, it's 36, less than 36 inches and within 60. So just some of these things you can actually look at the framing. So anyway, I'm done.